Awesome. Okay, let's hit the road on these questions. So typically in your paper 2 exam, your first trig question will be something like this. And so let's just have a quick look at how it's constructed, because it's a bit like, it feels a bit cluttered at first, but the good news is if you see enough of them, it kind of gets easy. So it says in the diagram below, there's this point P, which is x24. So it's basically this thing over here. And then it says is such that the OP is 25. And I suppose that's the 25 that they're talking about over here. It says angle ROP is beta. So there's this thing over here is beta. And then where beta is an obtuse angle. Okay, and then it says calculate the value of x, where x is clearly this thing. So find me the value of x. I want to know what the value of x is. And Fagelo, you are on the money. So a tip from Fagelo is that Pythagoras could possibly be helpful. I'll leave that tip to the students, but I want to get some answers here before I give anything away. So you can imagine the right angle triangle that's being formed. And you know that this is 24 and you know this is 25. And so what you're after is this thing here. So maybe we can say 25. Okay. Now you guys are on the right track with your 7. But when you square root something, there's actually 2 possible answers. When you square root something, in this case, there's the possibility of plus or minus 7. Now, if I look at the drawing, is x going to be plus or minus 7? So this is something to remember. Like if you square root 9, you get answers plus and minus 3. And the same thing happens here. You have 2 possible answers, but the only guidance you have is that the drawing tells you that in that quadrant, x is going to be something. Yeah, so in fact, the x is going to be minus 7 here. Okay, awesome. So that's a common, I marked many papers where students will get 1 out of 2 because they don't notice that sort of thing. All right, so now you've got a triangle and you filled out the 3 sides, which is often how these questions work. I want you to find me the value of the sine of beta. What's that going to be? What's the sine of beta going to be? So remember, with sine, it's always going to be over h, or in terms of this drawing, it's going to be y over r. So what's y, what's r? For me, this is a y, this is an x, this is an r. No problem, Shane. You can come and join us now. So I see Dawn is locked in an answer. Who? Darren? Fagelo? Yes. So the sine of beta is just going to be 24 over 25. So beta forms this angle, and then all we do is we read off the sides like this. Yeah, that wasn't too bad. So that's 1 mark in the bag. Now, the second question isn't just worth 1 mark, it's worth 2 marks, and that's because you have to do a first step. Who would like to come online and tell me what is that first step that I need to do in order to get both marks?
Oh, no, sorry.
No problem. Let's go to Figelo. Figelo, what is that first step that we need to do to get me that second mark?
Hello to everyone and hello to you, sir and ma'am. I think we have to reduce the cos 180 minus beta first.
Exactly. Yeah, exactly. So what do you get for that? What's the cos of 180 minus beta?
Yo, sir, I haven't started doing
Okay.
it.
No, that's fine. I'll give you some time. Awesome. Thank you, Figelo. Lesego, let's go to you. Yeah.
So I believe it would be negative cos beta.
Yeah, I would agree with you because, or let me just confirm, basically we know we're in this quadrant, and in quadrant 2, sine is positive, cos is negative. So it's minus cos beta. And so now we can answer the question, what is that going to be equal to? So that's 1 mark in the bag. So you're quite right. This is minus cos beta. So what is my final answer going to be using what I've done so far? Oh, what is the cos of beta going to be? So there's a minus there. And then this is going to be minus 7 over 25. Because it's minus, and there's another minus. So it's actually going to end up being positive 7 over 25. Yeah. Okay, so positive 7. I see that in the chat, Ayanda agrees with me. And yep, Poitamelo agrees with me. So just check that you understand why the double negative ends up being positive. And then I'd like everyone else, unless you have a question, you can go on to C. Find me the value of the tan of minus beta. And I'm not going to give you any hints this time. We have to think about what do we do with the tan, because we don't really have a negative beta. We only have a beta. So minus beta would be here. So we should get negative tan beta. So the reduction is going to be from tan negative beta to negative tan beta. And then the tan of beta, that's just going to be over a or y over x. So 24 over minus 7. And then that's going to end up being 24 over 7. And that is the answer. Are there any questions or comments about that? Let's just check our working. I'm pretty sure that they all look good to wrong. Oh, I took the wrong question here. Did I? No, I didn't. Sorry. This is just obviously cut one of the questions out. But yeah, the answers are all the same. So that's fine. All right. So that is typically the first question you get in trigonometry. And I'm not going to make you do another one because there's limited time today, but I'll just show you another question just to show you how similar there are. So this is from, I think, the one was 2017, the one was 2018. Can you see how it's the same type of question? Like they give you a drawing, you have to find t instead of x, but you're going to use the same idea as before with Pythagoras. And then you're going to evaluate these two things over here. So just give me a thumbs up if you feel like, no, I understand the method. The reason I'm not going to do a second question is I feel like in the time limited today, we'd be better off to do a different question, unless you guys completely disagree. Yeah, Lesego.
So in the previous question, you said that the angle or the angle between the vertical line and 17, for instance, is equal to that pieta. How is that so? Because the pieta goes around like the entirety of the angle, but it's not there.
Yeah. Okay. You know what you're saying. So here's what it basically goes from, is that you get this original generating angle, okay, gives you a triangle, okay? And that triangle is the one that you're going to work from for this bit over here. But when you do this bit, don't try and connect that to reducing on the diagram. It causes chaos. Rather reduce this by itself. And then once you've reduced it, you take the triangle that you formed to evaluate these. Okay. Because if I go, it's going to cause confusion if you go any other way. So first of all, reduce the cos of minus theta as a normal trig ratio, and you end up with, for example, cos theta, and over here, it's like it is. But you use this diagram when you figure out the three sides, you use those three sides to help you evaluate these things over here. Okay. That's the method that I would stick to. Anything more than that is not going to be efficient to discuss further today. All right. Okay. So here is a different type of question that I thought would be better to spend some quality time on because it looks different. It's not that different, but just take a moment to evaluate this. So it says here, if sine of 17 is A, without using a calculator, express the following in terms of A. Now, this gives students nightmares. And the reason it gives students nightmares is they don't know how to, the first step. They don't know how to make it more concrete. It's very abstract. It's like, what's A got to do with sine of 17? And how is this connected to this? And there's one really important step that I want to ask. Does anybody, oh, I think Rona knows where I'm going with this. Yes, okay. So Rona has suggested that thinking of sine of 17 as A over 1 is a very good first step. Rona, do you want to give us some more information? What else would make it a bit easier if I can almost draw some stuff? Any ideas? How do I, because I have to work with this stuff, I have to evaluate it, but I need to somehow connect it to here. So what I liked about Rona's idea, do Pythagoras. Donna suggested do Pythagoras. Draw a triangle. Oh, you guys have got this. Okay, so what I do is all of trigonometry is based around right-angled triangles. So I'm going to draw a right-angled triangle with a 17 in it. Now, because I've got the sine of 17 is A over 1, I'm going to go an A here and a 1 there. Give me a thumbs up if you understand why this drawing says the sine of 17 is A over 1, or it's, O over H. Give me a thumbs up if you understand how this drawing gets me to, why is it over 1? It's so that we make it a ratio, because anything over 1 doesn't change the value. A over 1 is still A. Okay, so now what happens is we can actually fill out two bits of information. We can fill out what this angle is, and we can fill out what this side is using Pythagoras. And using Pythagoras, let's just call this side, or what's it going to be? It's going to be some unknown. I'll make it X, but let's write this in terms of A. So let's just make this, what we say, question, let's just call it X. So using Pythagoras, 1 squared equals A squared plus X squared. And then to make X the subject of the formula, we get A squared minus 1 squared, or A minus 1, and X is just going to be that. So this is going to be the square root. Now that is a bit of a mouthful, but I suppose you're in grade 11, but this, once you get this triangle part, it makes sense. So 3, and then this would be 73 over here, I think, because 7, yeah. Okay, so that is step one, and it's probably the hardest step in the whole question. Now, I filled out my triangle. I want to know what is the tan of 17 using this. I want to know in the kind of thing, find me the tan of 17. Or maybe somebody can come online and even tell me, what do I need to do to find the tan of 17? Ah, have I made a mistake here? Sorry, guys, let me have a quick look. So when I bring this would be 1 minus a squared is x squared, and then 1 minus a squared. Well spotted. Thank you, guys. This should be 1 minus a squared. Love it. Love it. So, Lesejo, yeah. How do we get tan of 17 now?
I do believe that since tan is opposite over adjacent, then that means that the opposite being a over the adjacent, which is 1 or the square root of 1 minus a squared.
Yeah, that's exactly it. So, and that's what they mean by expressing in terms of a, because you've written it in terms of a, essentially. Try and do the sine of 107. What do you get for the sine of 107? How am I going to connect that to, I'll give a little bit of time, but you don't have 107 in your triangle. So that's your problem. And I need to evaluate this. I need a tip or help from the class. I see some clever ideas coming through. I need to connect this 107 to my triangle, and the triangle only has 17s and 73s. So Dawn has suggested a co-function. So a co-function is when we use the vertical. And so if I want to go 107, here's 107, and it is 17 degrees away from the vertical. Now in quadrant 2, sine is positive, so that's good news. So this will be positive, but instead of staying sine, it's going to become cos, because it's a co-ratio, cos 17. Now, once you know it's cos 17, now we can get the answer. So what is the cos of 17 going to be in terms of a? Yeah, Kakleko, let's go to you.
So it's going to be the root of 1 minus a
Squared, yeah.
over 1.
Perfect. And anything over 1 is actually just going to be that, eh? Because it's over 1. Loving it. Loving it. Okay, one more, then we're moving on from this type of question. We've got places to go, people to see. Let's see what we can do with this one. Sasetu has asked, how did we get cos 17? So Sasetu, what we did was we used what's called a co-ratio reduction. And the way we do a co-ratio is this little drawing I've got down here. And basically, I'll just do it again for you. So if you think of 107, the angle 107 is in this quadrant. And if you use the vertical axis, this is 90, which means this angle over here must be 17. And the way we reduce it is we say, okay, well, in this quadrant, sine is positive, so the reduction will still be positive. Then we say, what's the co-ratio of sine? It's cos. And then how far is 107 from the nearest vertical? It's 17 away. And so sine of 107 is cos 17. If you're unsure of how I did that, look at what's called co-ratios. It's a co-ratio reduction. In fact, I think I might do a co-ratio reduction for this one, because I'm thinking of, like, you don't have to, there are other ways to do it. You could go to the nearest horizontal or the nearest vertical. Both are fine. Yeah, Leseko.
So the squares on the cos and sine of the question are kind of messing with me, because I was doing reductions and then I realized those are there, and now
You just keep them there. So you treat it as normal. Leseko, were you going to the horizontal or the vertical when you were reducing the cos of 253? Like, what were you naturally? There's two ways to do this. Which one?
I usually go to whichever one is closer, so the lower one.
So were you going to the 270, the vertical?
Yeah, the 270, yes.
Okay. So if you imagine 253, can you see the nearest vertical is 270? So let's just think about that quickly. What quadrant are we in? So it's going to be here, hey? Quadrant number 3.
Times positive, everything else is negative.
Yeah. So this is going to be negative cos, wait, it's not going to be cos because it changes. So the 17 is great. So it'll be negative sine 17. And then what I would do is I would just square it like that. Yeah. However, some of you might have gone to the nearest horizontal. We'll still get the same answer in the end. Okay, so if we look at the sine of 557, that is a bit trickier, but I would say that if I want to visualize 557, I would go 360 on my calculator. Let's just see how close I get. So 360 plus 90 is 450, plus another 90 is 540. And so basically, it's basically going the whole way around, 360, 450, 540, and then it's going to be another 17 to get to 557. And I'm also going to be in this quadrant, except that I'm now going to the nearest vertical. Sorry, not the nearest vertical, the nearest horizontal. So this is going to reduce to sine squared, so negative sine 17, and then that's also going to be squared. And so the final answer here is going to be sine squared 17 plus sine squared 17. Let's just check my answers, and then it's going to be 2 sine squared 17. And then I have to evaluate that. I think I might have lost a couple of you, so I'm going to pull up the big answers just so that we can kind of go over them. Okay, so there's different ways of getting there. But if you think about the original, sine of 17 is a, so we get the 2a squared from that as the answer. So what have I done in summary? I took cos squared 253. In the model answers, they went to the nearest horizontal, which gives you that, not a problem. I went to the nearest vertical, and I got the sine minus sine 17 squared. In the second one, I went to the nearest horizontal, and I got that. When you square something, the negative is going away. Okay, so that's why the negative goes away. And then you've got 2 of exactly the same things, so that's why there's a 2. And then the last thing to ask yourself is, what is the sine of 17? It's just a. That is a tricky question, but I think take a screenshot. You can always think through it at a later stage. And I also realized that you could have got 5 out of 9 already. Okay, any questions or comments?
Mr. S?
Yeah.
Dawn is asking if you don't mind explaining 5.2.2 again.
So 5.2.2 is just making sure you use the co-ratio. That's all it is. Once you've used the co-ratio, the cos of 17 comes from the triangle itself over here. Okay, let me go to Katlego.
So can you please explain why the hypotenuse side is 1? I was like kind of like outside and I didn't really get to catch that.
Hypotenuse was 1. Okay, if you think of the sine of 17 as a, that was the very first bit of information we gave. A trig ratio always needs to be a ratio, and a by itself only has one part. But if I write a over 1, it's still a. And so now I have sine of 17 as a over 1. So this would be the a, and this would be the y, and this would be the r. Does that make sense? Okay.
Yes, sir. Thank you.
Cool. All right. It is time for a break. We have worked hard, ladies and gentlemen. I've taken it up a notch because I do want to test you. But let's start by just standing up and stretching out. Turn your cameras on, and let's just take a well-deserved break after, making our brains work hard.
Guys, please join us in the stretch. We've been doing very hard work. Give your mind a break.
Let's do it.
Put your cameras on. Let's see your lovely faces.
Yep. Oh, I can feel
Shout
the
out to Lisiho, Perelo, Darren, Shisana. Nice one, guys. Your body will thank you. Shout out to David.
Yep. Oh, that feels so good.
Don't
Shake it
get
out.
FOMO, guys.
Loosen those shoulders. After half an hour of hardcore maths, you need to loosen up those shoulders. Oh, I can feel, guys, I just got 10% smarter by standing up. Like, I think some of you got 20% smarter. Like, I can feel my brain's like, thank you. Thank you for
letting those brain juices flow.
Okay. Let's just do a quick brain break. Chop, chop. I want to know what these animals add up to. And we can go, basically, what is that going to be? The duck has been solved. No worries there. Donkey has been solved. Waitemelo, Miguelo, or the cow. I think it might even be here. So I get 5, 5, 5. Yep. And then remember there's 2 cows here. And you've got 5 on this side, you've got 9. So each group of cows is 2, but each individual cow is going to be 1. Which means this final cow is 1. So what is the final answer? I see answers appearing in the chat. Oh, you guys are too good. 5 times 10 by BODMAS is 50. 50 minus 1 is 49. So it turns out the answer to, who would have thought, a pig times a duck minus a cow is 49. That is some advanced algebra.
Awesome, guys.
Our farmyard friends. All right. So second type of question for tonight, proving identities. Now, before we start this, I want to know there are some important tools that we need to bring in our toolkit. What are the 2 basic identities that you need to know that you bring with you into this question? Over the chat, or put your hand up. what are the two basic bits of information that you need to take with you? Yeah, Nolotando, let's unmute you. What are the two bits of information?
Hi, sir.
Hello.
You should know that 10x is the same as sine over cos x.
Exactly. That is important fact number one. Do you have important fact number two?
Cos squared x plus sine squared x is equals to 1.
These are the tools that are going to make you succeed in these questions. Thank you so much.
You're
All
welcome,
right.
sir.
Now, you've got the basic bits of content you have to know. When you deal with identities, the golden rule is normally to work with the more complicated side, which we call either the left-hand side or the right-hand side. In this case, the left-hand side is clearly the more complicated. And so what I would do is I would write down that left-hand side, and my goal is to make it look like the right-hand side, which I'm going to keep an eye on throughout this question. But I want to give you 2 minutes to try and do it by yourself. But I will take questions from students who are unsure, but just see if you can, see if you can think about how would you begin to try and make the left-hand side look like the right-hand side, because then you've proved it. I'll give you some time. If you think you have a top tip for the class, pop it in the chat, or maybe you can just let us know. I'm sure in the room, we have all the stuff that we need to make this happen. David, yeah, what's your comment, question, or tip?
Okay, in my opinion, the first idea is to change 10x into sine x over cos x.
David, I think you're giving very good advice today. That is very good. I like it. In fact, I like it so much, I'm going to do it. So. Okay, that's good news for us, but we still have a problem that we're trying to make it look like the opposite side. And so I'm going to do some cleaning up, and I'm going to get sine squared x over cos x plus cos x. I have a bit of a problem now, though. I feel a bit lost in the woods. Does anybody have another tip for me? Okay, LCD. I like that. We're going to say, so Dawn is looking at where she needs to go to. And in the end, I only have one term on the right-hand side. At the moment, I have two terms on the left-hand side. And so I need a way to connect them. Now, normally when we add two fractions, we need a lowest common denominator. The problem I have is that cos of x isn't a fraction, but because I've been doing this a while, I know a trick to make anything a fraction. You put it over 1. Okay, so can you think about what the next step is going to be? If I put that over 1, what am I going to try and do to bring those two together? Yeah, Nolotando.
Hi, sir. So
Hey.
you're going to use the LCD, which is you're going to multiply sine squared x over cos x with 1, and then cos x over 1 with cos x over cos x.
I like it. Okay. What I'm going to say is that really this part over here is all good. It has a denominator, but the problem is you need to artificially force a way for the second term to have the same denominator. And if you think about what cos x over cos x is, it's just 1. Anything over itself is 1. So you haven't changed the nature or the value of the identity. And so all that you're going to do is, if you do this, okay, you're going to get that. Because there's a cos x times a cos x gives me a cos squared x, and then we get that. So that is a really important step. And I just want to highlight, what did we do? We forced it to have the same denominator by basically applying the top and bottom by the same thing. When you do that to a fraction, you don't change the fraction because these can easily cancel out. And this cancels out. This is 1. It doesn't change the value, but it does this helpful changing thing. Okay, last step. You put them together. Okay, it's not the last step. There's still one more step. What do we now need to do? At the beginning of this, sine squared x plus cos squared x is an identity that we spoke about. And we recognize, there it is, it's 1. So 1 over cos x, and good news for all of us, 1 over cos x is the right-hand side. And so you've proven it. So as we go back and look over this identity question, all right, what we need to do is we need to ask ourselves, well, step 1 was to replace tan x. Then it was to create this artificial denominator. And then I'd say the last important step was to recognize that that was 1. Okay. I think we need to do another one like this. So let me enlarge this one. So I want you to try and prove this identity, but while you're starting on that, I will take any questions on this one. Yep.
Mr. Yes, Younger has a question.
Yeah, Younger.
Afternoon, sir.
Hello.
So on the previous question, like after you, where you multiply by cos x over cos x, where does it come from?
Say that again. Oh, where does the cos x over cos x come from?
Yes.
Okay, I made this up because I really wanted this fraction to have a denominator of cos x. So I'm using the idea that if I chose any number in the world, doesn't matter what it is, anything over itself is 1. So I basically multiplied this fraction by 1. And when I did that, it didn't change the value. It's still cos x. But what's good is that basically I got my cos x on the bottom that I needed. And then the cos x that was already there on the top, it became cos squared x. Does that help, Younger?
Yes, thank you, sir.
That's a well-known trick in identities. We often use that to bring 2 different terms together. So it's worth remembering and you know, seeing it as we go forward. And there's also more than one way to do an identity. I think for me, the more difficult side looks like the right-hand side. I'm not saying it's the only way to do it, but that is what I'm starting with. And we might need some more tricks to deal with this. But it's up to you guys. Yeah, Leseko. Let's unmute you.
So this may be a shot in the dark, but if I remember correctly, I think 1 minus sine is No, I could be wrong, actually.
I think I know you're going the right way, but it's just there's actually two ways to do this question. And so either of them will get you there. Are you focusing on the denominator?
Yes,
Is that
sir.
what yeah. There's a little trick that you use, and there's two variations of it. But I was thinking, wouldn't life be great if we could make this 1 minus sine squared theta and do some replacement? But there's a couple of different variations of this. So I'll go with whatever you guys want to do. Don't you think you want to multiply it by something? That's my tip. Let's see if this would work. So what I'm going to do is, Lebo is pointing out, I'm not going to multiply out the top bit. Okay, so all I'm going to do is I'm going to leave it like it is. And so I'll just leave it like this. But on the bottom, what is 1 minus sine squared theta? Do you agree that that's cos squared theta? So this is going to be cos squared theta. And then over here, we're going to have this like that. Okay, we're not there yet, but I do agree. I see the finish line now. So what do you think my last step is going to be? So cos squared theta is actually the same as cos theta times cos theta. So what do we need to do there? Yeah, cancel out the cos thetas. Yeah. And I think happiness is upon us, ladies and gentlemen, because what I see is 1 plus sine theta on the top, and on the bottom, I see cos of theta, which is what the left-hand side is. Okay. Okay. So what I'm going to suggest is that with this particular identity question, that you have a look at this question again on the recording. And if you look through it in the recording context, I think it will make a lot more sense to you at that point. It's just that we're trying to do too much at once tonight. And that's what's getting ahead of us. Okay. I'm just going to spend the last 5 minutes talking about a trig equation and the method for solving trig equations. And then I'm going to call it for tonight. So basically, if we're solving a trig equation, if I gave you something simple like this, sine of x equals 0.4, I just want to make sure that you all have a clear understanding of how to approach a trig equation when finding a general solution. So if I say to you, find me the general solution for the sine of x is 0.4, step 1 is always going to be to find a reference angle. So find me the reference angle for the question sine of x is 0.4. Okay, so we get 23.58. Okay, the second step is going to be to ask you, in what quadrants is sine positive or negative? In what quadrants is sine, sorry, not positive or negative, in what quadrants is sine positive? Yeah, so because it's positive in quadrants 1 and 2, our answer is going to be in quadrant 1 and 2, which is x or 180 minus x. So what I do is I go, here's for quadrant 1, here's for quadrant 2. And I say for quadrant 1, x is going to be equal to 23.58. For quadrant 2, x is just going to be 180 minus 23.58. And 180 minus 23.58 is going to be 156.42. Okay, so that is step 2. Now, what about the general solution bit? In order to make a trig equation a general solution, you have to add one more bit, and it's this k times 360 thing. So 23.58 plus k times 360, or x is 156.42. And so what we're going to get is the 3-step process for solving a trig equation. And you can go back to earlier videos in the year when I did trig equations if you want a bit more detail. But basically, step 1 is to find a reference angle. Step 2 is to know what quadrants are you in and what format will they have. And then step 3 is just the general solution. So, and if you want to check whether this is right or not, type into your calculator the sign of 23.58, and you should get quite close to 0.4. Give me a thumbs up if you're getting that. Or you can try 156.42, try and find the sign of that, and you get about 0.4. Okay, awesome. So I think that unless there are any other additional questions, there are more complicated trig equations, but what I'm going to recommend is that you go back to the section earlier in the year we were doing trig and have a look at the way I explained trig equations at that stage, because I did a whole bunch of sessions on them, and it'll be better than me trying to squeeze in too much in this last 2 minutes. What is the equation on number 3? It's 23.58 plus k times 360, or x is equal to 156.42 plus k times 360. I'll just show you, in fact, here's another example of how you lay it out. So they've added an extra step, but just have a quick look here. Something that I must mention actually is when you're determining the reference angle, you ignore the negative sign. So say, for example, I'll just look at what I've got on the screen here. When I want to find, if I want to solve this trig equation, the cos of theta equals minus 0.866. When I find the reference angle, I ignore the negative. So when I go shift cos 0.866, I get 30 degrees. I then ask myself, what quadrants is cos negative in? And cos is negative in quadrant 2 and quadrant 3. And in quadrant 2, it's going to have this form. So 180 minus x. And in this quadrant, it's going to have a form 180 plus x. So that's why the solution has this form over here. And so I just want to point that out, that if there's a negative and you're finding the reference angle, you ignore the negative when finding the reference angle, but you incorporate the negative in the way that you choose your quadrants. Yeah, exactly. But again, if I try and do more of that now, it's squeezing too much. I would suggest having a look at an earlier Watobe video about how to do that. And yeah, Lebo, if you could put the link to the quiz.
Okay,
yeah.
Mr. Ace.
Thank you guys for everything tonight. It's just been good to teach you, and I will continue next week with circle geometry.